Okay, good morning. Today I'm going to be looking at Algebra 2, Chapter 9-5 on geometric series. So a series is where you add up a whole bunch of things in a row. You take a sequence and you add them all up. There are a couple of formulas here. Actually, one new one, and I put up the explicit formula as well, which is not new, something we've already looked at. So geometric sum formula is S of n equals a of 1 times 1 minus r to the nth power, in parentheses, minus 1 over r. A of 1 is the first term in the sequence or series. R is the common ratio, which you can always find by taking the second number and dividing it by the first number. And n is the number of terms in the sequence, okay? And, again, we have the sum. That means sum in mathematics. Usually it starts from 1 and goes to something. If I had 3 of them, that would be 3 numbers in the sequence. Usually it's a bigger number than that, but maybe you have a different. The explicit formula comes after the sum. So here's an example of what I'm talking about. This could be an explicit geometric series. So 2 is the first number in the sequence, because that's a of 1, and it has 3 numbers in the sequence. So if I was to plug in 1, 2, and 3 for n, I would get my 3 numbers in the sequence, and then you'd add them up. Okay, so 2 is the first number. And then if I plug in 2 here, would be the second number, because 1 minus 1 is 0, 3 to 0 is 1, okay? So that's how I got the first number. If I plug in 2, I get 2 times 3 is 6. And if I plug in 3, 3 minus 1 is 2, 3 to the second power is 9, 9 times 2 is 18, which means my S of n, the whole sum, would be 26 if you added those up. And you could also use the S of n formula, which is up here, and you'll notice that you'll get the same thing. The common ratio is 3 to the nth power. There's 3 all over 1 minus the common ratio is 3. So you'll see this should come out the same way. 3 to the third is 27, and 27. 3 to the third is 27. 1 minus 27 is negative 26 times 2 is negative 52 over negative 2 also gives you 26. So you'll see you get the same answer either way, all right? So certainly if it was only 3 numbers, you might be just as easy doing what I did on the left compared to what on the right. But if it was 100 numbers, you certainly wouldn't want to do what's the way on the left, because it would take way too long. All right, so anyway, that's the way that stuff works. So let's start out with a basic kind of problem. What is the sum of the finite geometric series? Finite, once again, means it has a beginning and an end, okay? Infinite means it goes on forever, okay? So for this one, I would really like to know how many numbers are in that sequence, okay? So if I'd like to know my explicit formula, in other words. So I'm going to use that A of n formula to find it. So first thing, I need A of 1. What's the first number in the sequence, which is 3. Next thing I need is the common ratio. So if I take the second number and I divide it by the first number, I get the common ratio. So now that I've got that, I can plug it into my equation, which is the A of 1 times r to the n minus 1. So I get A of n equals 3 times 2 to the n minus 1. All right, now next, I want to know which number 3072 is. So I'm going to plug 3072 in for A of n, 3 times 2 to the n minus 1, and try to solve this, okay? So if I divide by 3, I will get 1024. Now, you could use a graphing calculator to solve this if you want to punch in 2 to the n minus 1 and y equals 2 to the n minus 1 and y equals 1024 and look for the intersection is one way to do it. Or you could figure out that 1024 equals 2 to the 10th power, okay? And therefore 2 to the 10th equals 2 to the n minus 1, therefore n has to be 11. All right, so I know there are 11 numbers in the sequence, okay? So n equals 11. So you did one of those ways to figure that out. I know that's not the easiest thing in the world, but that's what we got for this one. So I can do the S of n now. I can find out what the sum is. So my S of n formula is the a of 1, which is 3, times 1 minus the common ratio, which is 2, to the n, and n is 11, over 1 minus r, and r is 2. So if you plug that into your calculator, you should get that the sum equals 6,141, and that's the answer. Okay? So that one. Next one. So they gave us the sum in sum form, in summation form, okay? So remember, this is 20 minus 1 is 20 numbers in that sequence, all right? So there n equals 20. I just took that by looking at those two. What you actually do with those is you go 20 minus 1 plus 1. The only thing that gets tricky with these is if the bottom number isn't 1, say I got this, and it starts with 3. No, let's make it smaller. I'll say it'll start with 18. That's not 2 numbers in that sequence. That's actually 3 because you count the 18. So it's 18, 19, 20. So you subtract them and then you add 1. Right? Just like if I assigned you problems 18 through 20 for homework, you'd go like, oh, that's probably 2 problems. Then you go home and find out it's actually 3, right? Because you got to do 18, 19, and 20. You're including that bottom number. So anyway, that's how you do that. So subtract them and then add 1 because you're including the bottom number. So anyway, that doesn't come up very often, but I figured I'd point it out. So this one, I got 20 numbers in the sequence. The first number is 4. Okay, my common ratio is 1/2. So now I've got all the 3 things I need for that formula to find out the sum. This is the sum formula, a of 1 times 1 minus r to the n over 1 minus r. So I can just plug in my numbers now and then go to my calculator. Oops, I got that backwards. S of n equals a of 1, which is 4, times 1 minus 1/2 to the nth power, 20th power, big one, all over 1 minus 1/2. All right, so make sure you do your exponent first. Before you do the subtraction, don't subtract and then do the exponent. So if I go 0.5 to the 20th power, I get 0.0000, there's a whole bunch of zeros, 954, okay? And then subtract that from 1. And then multiply that times 4. I'm getting 3.99685. And then divide that by 0.5. And I get S of n is equal to 7.9999. So we're going to say that's pretty close to 8. Okay? Approximately 8. All right, if you round off a little bit, which is just fine in this case. Okay? So there's your second problem. If you have any questions, please bring them to class. Sum. What's the sum of these? Okay, so I know this is only like 6 numbers, and the easiest way to do this one is probably to add it up in your calculator, but let's say you're not doing it that way. Let's say you were going to do it a little differently. Let's say I was going to do it with a formula. This formula here, S of n equals a1 times 1 minus r to the nth power over 1 minus r. I would need 3 things, right? I need the first number in the sequence, I need the quantity of numbers in the sequence, and I need the common ratio. A of 1 would be negative 15. And 1, 2, 3, 4, 5, 6 numbers in that series. Okay, there are 6 of them, just count them up. R is the common ratio. Take the second number, divide it by the first number, which gives me negative 2. Now I can plug in my values and I will get my answer. Okay, so I got negative 15 times 1 minus R is negative 2 to the nth power all over 1 minus R, which is negative 2. So this is over 3. This is the S of n formula. Okay, so negative 2 to the 6th power can be a positive number, 64. So 1 minus 64 is negative 63. Times negative 15 will give me a positive number. And then divide by 3. I'm getting 315 as my answer here. Yep, that's what I got when I did it the other way. All right, so that's it. If you got questions on that, please bring it to class. That's the end of number 3. Number 4. So once again, they gave me it in some summation form. They want to know what is the sum or the directions, the same directions as it was for the last one. So I see there's the explicit formulas there. So I know that, for example, the first number is 5. I know that the common ratio is negative 2. Okay. And I need to know the quantity of numbers, which I will get from looking at these 2 numbers right here on the sum form. It goes from 1 to 10, which means there are 10 numbers in that sequence. So, if I wanted to know what the 5th number in that series is, you just plug in 5 for n, and then take negative 2 to the 4th power once you subtract 1, and then multiply by 5, and you get your answer, okay? However, in this case, we're looking for the whole sum for all 10 numbers. So I'm going to use that same S of n formula, okay, which is a1 times 1 minus r to the n over 1 minus r. So if I plug in the 5, negative 2, and the 10, I get that. Now it's calculator time. Go punch that into your calculator. And if you do that, for the numerator, I get negative 5,115 over 3, which gives me 1705, and it's negative, and that'll be what the sum will be. Now it's always good to look back and be like, gee, does that make sense? It does make sense. This is a negative number to an exponent, and especially if I have the first one, well, yeah, it could be a negative. So yeah, it does make sense anyways. All right. Next one's a word problem. To save for a vacation, you set aside $100. For each month thereafter, you plan to save 10% more than the previous month. How much will you save in 12 months? Okay, so with this kind of problem, I like to try to figure out the first couple numbers in the sequence, okay, or series, which means I have, and these are nice numbers because it's hundreds. So 10% is 0.10, okay? So if I take 0.10 and I multiply it times 100, I'll see how much more I'm going to save next month than I did this month. And if you do that, you get 10. So $10 more next month than the first month. will be $110, okay? So, you add it to the 10. I'd like to do the one more, even though it's probably overkill. If I took $110 and I multiply it times 0.10, because this will tell me how much more I do the third month than the first month, or the second month. And if I do that, I get $11. So 110 plus 11 is 121. So that's the first few numbers in my series. So I got my numbers in the sequence, the first three numbers, right? Now I've got everything I need. I need A of 1, I need R, and I need N, okay? So if I'm looking at this, the first number in the sequence, A of 1, that's the 100. R I get by taking the second number, dividing it by the first number, which is 110 divided by 100, which gives me 1.1. And the third thing is I need N. In this case, N is 12 because there's 12 months that I'm looking to save. So I can just take those three numbers now and plug them into the S of N formula, which I have here. And when I do that, I boil it down, as you can see. Remember to do the exponent and then the 1.1 to the 12th power first. And if you boil it down, you should get $2,138.34. Round off to the nearest penny since it's money. So that's the answer. And then it's always nice to look back and be like, gee, does that make sense? If I saved $100 a month and then a little bit, after 12 months, how much would you have? So $2,000 doesn't seem out of the, seems reasonable. Okay. If I was saving, $100 a month, start out that, and I saved $1 million in a year, you might want to go double check your work. Okay. All right. So next one. Number 6, find the sum. 9 minus 6 plus 4 minus 8 over 3 plus ... Okay, so I need three things for my S of N formula. Okay, I'm trying to find the sum. And once again, that formula over and over again is A of 1 times 1 minus R to the N over 1 minus R. A of 1 is the first number in the sequence. Common ratio I get when I divide. That 6 is like negative, okay, because there's a subtraction sign there, so you want to make sure you get that, which gives me negative 0.66 repeating, all right? N is how many numbers there are? Well, they told me right over here N is 12, so I can just plug that in. So if I plug these numbers into the formula, N is 12 over 1 minus negative 0.66 repeating. Okay, so if I take those numbers and plug them into my calculator, you will get something like this, 8.93 over 1.6 repeating, which gives me approximately 5.358. Okay, so that's what I'm getting for an answer. That's approximately the sum, all right, for 12 numbers. All right, that's it. So next, I got a couple of these quick problems here. I told you before, a finite geometric series is one that has a beginning and an end. An infinite geometric series is one that doesn't have an end. It keeps going forever, infinite, meaning infinity. So there's kind of two different kinds of these. There's either the infinite series that has a sum, or there's some infinite series that don't have a sum. In order to tell which ones have a sum, you look at R, okay? So if R is less than or equal to 1, the absolute value of R, meaning between 1 and negative 1, then it has a sum, okay? If R is bigger than 1 or less than negative 1, or the absolute value of R is greater than 1, then it doesn't have a finite sum. All right, it has an infinite sum, which means it goes to infinity. But finite, something you can actually measure, it'll only have that if the absolute value of R is less than 1. So if it has a finite sum, we say that converges. And if it has an infinite sum, we say that diverges, okay? And there is a formula there to find out, what is the sum, and it's pretty straightforward or pretty simple. S equals A of 1 over 1 minus R, okay? So that's the relevant information for the next couple problems. You'll get more into the finite and infinite series when you get into calculus. But anyway, so this one, number 7, does the series converge or diverge? If it converges, what is the sum? So the first thing I need to know what R is, because that'll tell me what kind of series it is. So the same thing. If I take the second number and divide it by the first number, I'll get R. Anything divided by 1 is itself. So that's 0.5, which means the absolute value of 0.5 is 0.5. So 0.5 is less than 1, or equal to, it shouldn't have that there, which means this is that first type. It converges, and therefore it has a sum. So it converges, and S equals, the sum will be A of 1 over 1 minus R. And A of 1 is still that first number in the sequence, which is 1. And 1 minus 1/2 is 1/2. And if you divide that out, you get 2, which means the sum will be 2 if you were to add them all up, or it would approach 2, I guess would be the other way to say it. Okay. Now this one, number 8, they gave it to me in sum. See, it goes from 0 to infinity. Over here, the infinity goes from 0 to infinity. This is my first number in the sequence, and this is my common ratio. So -5 over 4 is my common ratio, and I want to know if I take the absolute value of -5 over 4, what do you get? So that's actually 1.25 if you do it out. And since that is greater than 1, this diverges. And since it diverges, there is no sum. Okay, so that's actually it for that. And that was actually my last problem. I just wanted to show you a couple of those. And that's all I got for today. You guys have a great night. And if you have any questions, please bring them into class. Thank you very much.